Hey, so welcome to section 8.3. This is it, the conclusion of our year together. Uh, who'd have thought it would have ended like this? But anyhow, one more to do, one more set of little tests or activities to do. Tests, we'll count them for. All right, so section 8.3 to enhance on A2 and A1 in the nervous system in physiology is basically a focus on the eye and the ear in this, but with some other little applications there too, two things. So receptors, so sensory perception. So let's move on. So sensitivity describes the ability of an organism to detect external and internal changes and then respond. A receptor detects these changes. While I bring up all of the receptors here, excuse me, bring them all up there. Okay, so receptors detect these changes and then generate impulses, which are relayed to the brain and then to the effector organs. There are different types of receptors that each recognize a different type of stimulus. And these are the four in an overview that you have to know. And on this diagram, especially the little bit of mechanoreceptor in the ear and the eye are going to be highlighted. So a mechanoreceptor is anything that detects movement. Okay, anything that detects movement, sound waves, that's how you hear, through vibrations of sound waves in the ear. Pressure, baroreceptors, eustachian tube pressure, touch and stretch, pressure receptors in your skin. That a little different than touch sensation. We're talking about whether you feel, all right? So basic location of mechanoreceptors, your skin, as I said, the ears, arteries for blood pressure as well, receptors. A chemical receptor, basically found in your nose and tongue, but there are some other tissues around, especially in other organisms that have in other tissue. So those are detect molecules, detect solutes, detect differences in pH. A chemoreceptor, chemical receptor. A thermoreceptor, heat and cold. Your skin, in your brain, the hypothalamus. A chemoreceptor. A photoreceptor, photo meaning light, okay, which detects the visible light spectrum, 400 to 700 nanometers. And of course, we use the eye, the retina for that. All right, so we take a look there. Now, the eye and the ear are the two ones that are covered, but it is going to give the nose its equal, well, it's not its equal, it's 2 minutes. So there's your olfactory. So detection of chemicals in the air by many different olfactory receptors. So let's take a look. At the back of your nose, there's a patch of tissue that's called the olfactory bulb or the olfactory epithelium. And within that is embedded chemoreceptors. And the chemoreceptor, all right, this chemoreceptor is lined with mucus, all right, mucus cilia, in which odorants, such smells that you smell, okay, dissolve into. I'll try to bring all that up there. All right, dissolve into before binding to chemoreceptors. So that you bind an odorant, a molecule triggers an impulse, travels to the brain via the olfactory nerve, and that is one of your cranial nerves that goes right to the brain. All right, to the brain. The combination of olfactory receptors determines the scent perceived by the brain. Okay, there's going to be a little bit of what do you call that? A video that I recommend you watching along with this. It's good to see there. So you can see the olfactory bulb here in this diagram, highlighted there through the ideas of sensory. You can recognize a sensory neuron from now. All right, sensory neuron, the odorant sense to the brain, olfactory nerves or receptor. All right, it's the combination that activated plus your frontal lobe memory of what you have smelled. All right, so that ends this screencast, the introduction.